Hi guys, it's Simon C. Welcome to this new AI Radar. The European Parliament overwhelmingly approved the EU Artificial Intelligence Act, a sweeping package that aims to protect consumers from potentially dangerous applications of artificial intelligence. The legislation takes a risk-based approach, introducing restrictions based on how dangerous lawmakers predict an AI application could be. It would ban tools that European lawmakers deem unacceptable and limit technologies simply deemed high risk. Furtherly, applications not explicitly banned or listed as high risk are largely left unregulated. It also takes aim at the recent boom in generative AI, creating new obligations for applications such as ChatGPT that makes text or images with human-like flair. Companies would have to label AI-generated content and publish summaries of what copyrighted data is used to train their tools, addressing concerns from publishers that corporations are profiting off materials scraped from their website. Mistral AI, a French artificial intelligence startup founded by former Google's Deepmind and Meta researchers, has raised 105 million euros in seed funding, making it the largest ever seed round in Europe. It plans to launch a large language model similar to the system behind OpenAI's ChatGPT in early 2024, using publicly available data to avoid legal issues and copyright backlash. A large part of the funds raised will be used towards rendering the computer power to train it. The company is focused on open source models and datasets and aims to cater to enterprise customers. The funding round, led by Lightspeed Venture Partners, values the company at €240 million, $260 million. This is a significant milestone in Europe's AI investment landscape, with over $4 billion invested in AI-related companies in the region this year. Meta's chief AI scientist Yann LeCun proposed a new architecture to create machines that can learn internal models of how the world works. As the first step on a roadmap he delineated a year ago for how we might get to more human-like superintelligence, and setting a radical departure in many ways from how previous computer vision models work. Indeed, this model, the image joint embedding predictive architecture, I-JEPA in short, learns by creating an internal model of the outside world which compares abstract representations of images. I-JEPA delivers strong performance on multiple computer vision tasks and is much more computationally efficient than other widely used computer vision models. It can also be used for many different applications without needing extensive fine-tuning. Meta's paper on I-JEPA will be presented at CVPR 2023 next week. You can already find it preprinted on archive.org. Self-supervised learning from images with a joint embedding predictive architecture. And they are open sourcing the training code and model checkpoints on GitHub. I-JEPA is a method for self-supervised learning. It predicts the representation of part of an image from representations of other parts of the same image. This approach learns semantic image features without relying on pre-specified invariances to handcrafted data transformations, and without having the model fill in pixel level details. Meta's internal audiocraft team has also released AI Music Gen, an open source project that uses a transformer model to predict the next section of a song, and Meta's encoder audio tokenizer to break down audio data into manageable components. Music Gen, in short, is like a music version of ChatGPT. You enter a brief text description of the type of music you want to hear, click generate, and the artificial intelligence quickly creates a 12-second long track according to your instructions. Let's check it out. Heavy metal mixed with cumbia cordobesa. Cool. It was trained on 20,000 hours of licensed music, including 10,000 high-quality internal tracks and data from Shutterstock and Pond5. Human testers favor the performance of the 1.5 billion parameter model, which excels in creating high-quality audio. Okay, you can find it open sourced on GitHub. In the audiocraft repo. Okay, in the paper recently published on Nature, Deepmind introduced Alphadev, a new AI system that uses reinforcement learning to discover enhanced computer science algorithms, surpassing those honed by scientists and engineers over decades. Specifically, Alphadev had discovered faster algorithms for sorting, a fundamental operation in computing which led to improvements in the LLVM libc++ sorting library, C++ main library, that were up to 70% faster for shorter sequences and about 1.7 faster for sequences exceeding 250,000 elements. It has also found a way to speed up a key algorithm used in cryptography by 30%. These algorithms are among the most common building blocks in software. It can make a huge difference, cutting costs and saving energy. Here you can see the libc++ review for the sorting algorithms. These algorithms are among the most common building blocks in software and can make a huge difference. Deepmind estimates that its new algorithms are now being used trillions of times a day. In particular, Alphadev is built on top of Alphazero, the reinforcement learning model that Deepmind trained to master games such as Go and chess. To play well, Alphadev must search through an astronomical number of possible moves. Deepmind chose to work with assembly, a programming language that allows algorithms to be broken down into fine-grained steps. Some experts, though, doesn't think that the results should be oversold. Alphadev only uses a subset of the instructions available in assembly, making it harder to compare Alphadev with the best reliable approaches. Okay guys, it's all for today. If you like the robotic voice, hit the subscribe button and subscribe to my channel. Bye.